This Hangout is live on air. Hello, hello world. Hi YouTube, if you're watching this later. How is it going? So we're just setting up the Hangout right now. We're just kind of sharing the link and stuff. We will be with you very, very soon. Let's grab the link. And so yeah, so please do join us if you're watching this. The link is going to be in the comment of the actual Hangout page. So if you're watching this, you should be able to grab the link in the comments. Something share. In fact, it's there twice because I typed it twice. But yeah, so what we're going to talk about today, Mark? What are we going to talk about?
Well, I think we should talk about the second section. We've already put the first section out there now. I'm going crazy to try and get the second section done. I'm having so much fun doing it. Yeah. And I think there's a lot of good content on this one as well. So even if you are experienced, we're hoping that some of it can be quite fun, even if you do know how to do it already. So I'm looking forward to doing that. It's been quite fun doing it. So I'm hoping you guys can have fun with it too.
I've got to say, even on screen, the beard is quite impressive, Mark. It's I now know why you're doing it, which is like you're going to dye it white and then be Santa Claus. And clearly, it's like that's your hidden talent, right? Your Santa Claus is just like a secret hero identity that you teach FSharp on the sped to cover your tracks.
I don't have many talents, so maybe that's the.
But yeah, so yeah, the second section is definitely looking quite good. Hi, we have a viewer. Hello, welcome. So don't forget you can join us as well, so you can chat to us directly by clicking the link if you just joined us. So
I would like the link here so I can post it on Twitter actually.
You can find it on the Hangout page on Google+. So yeah, so we've got a really cool second section, I think, for the beginners course. If you haven't heard yet, the beta is now released. So beta is now opened for our beta backers. They're starting on the introduction section, which is kind of like the section for beginners. We already have several people who have committed their username to GitHub as part of the course, which is awesome. So we've had several pull requests already for people to share their username, their names, their Twitter handles. We'll be doing something with that information. We'll probably be doing something with your Twitter handles if you've got something. We'll be playing around. We haven't yet, but we will make more use of it. So yeah, so that's basically where we're at. We've got the second section going, and we'll wait until a few more people turn up, and then we'll go into what went into building the second section. Mark might give you a live demo of the section itself. In particular, show you some of the images he's already created using the code, which sounds pretty good.
Yeah, if I can get my laptop working.
Right.
So, technical issues and all that.
Yeah, developers, right? So I'm actually going to go get some lights because we've got quite poor lighting right here. So Mark's going to entertain you somehow.
Okay, let me try and throw something at you. But give me a few seconds, and I'll show you some of the things that I'm hoping that you guys will be able to get on with as well when you have a go at what we're going to be doing. So let me just revert my repository because I've got some broken changes in it. I'll share some spirographic images with you. So git cd documents.
So, Mark, what can you tell us about? Whoa, how is that?
It's very bright.
Does it help with the image? Is it less grainy now?
I think it's right, yeah. It seems much better.
That's much better. Hi. Good. Awesome. So yeah, so let's talk about the course. Let's talk about the demo of the section. Wow, I see you just command line. You got some images to show us.
I'm learning very quickly how to do the command line. It's, being a Windows dev, I've been using point and click all these years, and I've just discovered the joys of the command line. I feel like I'm becoming a real programmer all of a sudden.
So
it's quite cool.
Yeah, some of you should definitely let us know about your experience in the command line because we've got quite a wide range of experience on the course and the backers. We've had the backer survey, and there's quite a wide range of experience amongst you. So that's quite interesting. I would love to hear more about kind of what your experiences are. So yeah, so the topic of conversation for those of you who've just joined us is talking about the second section, talking about the beta, talking about the schedule, and what's going on. So cool. So if you have your question, don't hesitate to ask them in the comment or in the Q&A box, for sure.
All right, let me see if I can share this with you guys. And I'll put it onto, if I can, the Google Hangout page.
Please, and what you can do as well is join the Google Hangout using the link, and then that way you'll be able to share your screen, which will be quite useful.
This one here.
Yeah. Cool. So for the viewers who are already here, don't hesitate to join us on the actual Hangout. The link is on the Hangout page, and you should be able to join us and talk to us live. So if you're not afraid, please feel free. Got an icon right here. Click on this and allow.
Sorry, I'm such a technophobe.
Right, and we should see Mark. Be careful that you're in frame, Mark, on this one as well. Cool. So Mark is now connecting to Hangouts. We were shutting down. So that he can show you the screencast. And it may be worth if your microphone on your Hangout doesn't do pictures. It's correct. Yeah, please mute microphone. Excellent. So yeah, so Mark will now show you some of the stuff we've been working on for the second section, some of the images especially that he's been working on for the spirograph section, which is quite exciting. So if you go to share your screen first, if you click on this, there's a little down arrow, and go to, yep, I think it's present to everybody or something like that. Well, you should be able to share your screen. There should be an option to share your screen. Maybe in the.
Oh, there we go. There's the screen share.
There we go.
Okay, so let's have a look at that.
No, you don't want to share. I think.
I'm going to say over the top, right?
No, you want to share the entire screen. Yeah, here we go. Great.
Okay, so if I can get this working. I've managed to create some nice little spirographs. Some of you may have already seen them on Twitter, but the results, I think, are pretty impressive. I think that's the sort of stuff that hopefully we're going to get around to doing. I'm looking forward to showing you how to do this, in fact. Plotting our own lines, learning the algorithm to plot polygons and curves.
And what's interesting is this entire thing is actually built from pure pixels, right? We're just talking about pixel manipulation. We're not using a drawing library. We're literally drawing pixel by pixel. And it turns out you can get some pretty cool stuff going on with just pixels. That one's quite faint to my actually, yeah, zoom that in. Yeah, cool. Yeah, so all this kind of stuff is basically one of the introductions to programming that seems to work very well. And the reason it works so well is it's because it's so, it's basically a constructive approach, so it's especially good for beginners. We're really building abstractions up one layer at a time, literally one idea at a time. And we're really careful to kind of not rush beginners with new concepts. It's very easy as experienced developers to kind of go nuts and go straight into more advanced concepts. However, for this to work, for something like a course to work and be accessible to beginners, the concept has to be really carefully managed. So this is another one of Mark's rosettes that we're going to be building. So the concept has to be carefully managed, and it turns out Logo is a really great kind of the ideas behind Logo of line drawing and graph drawing are some of the really great ideas in terms of educational, from the educational perspective. One book in particular that's highly, highly recommended is called Mindstorms.
So I can find a link to it.
Yeah, if you put the link, I've got a paper copy just here. Unless you've already.
I've still got your copy of that.
So Mark has stolen my copy, but Mindstorms, if you're interested in educational books and educational, especially the how to use computers to teach, is a fantastic book.
You're looking for this link particularly, yeah.
Well, can you share it on Google, the actual comments actually? So that's the book itself, Mindstorm by Seymour Papert. So yeah, definitely have a look at that book if you haven't met it before. We're trying to kind of emulate and learn from the approach it's described. When was it published, Mark?
I think it's 1993.
That's the re-edition, or is
that was the second edition that I'm reading at the moment. So they basically started doing their work in the 1960s, and they've been observing children, how they learn, and they decided that children can learn quite complex ideas from a younger age than was originally thought possible. And that was because they put them in like certain worlds or scenarios and allowed them to learn whilst in those scenarios. So if they wanted to learn geometry, they gave them the turtle and allowed them to create their own shapes with it. And then, lo and behold, they were learning magic numbers like the number 60. And if they had all the angles of 60, they would create an equilateral triangle. They learned magic numbers like 90, so they could create squares. So it was all a learning experience, but they weren't learning maths formally, but they managed to get those ideas and concepts underpinned just by playing. So the book promotes that sort of aspect of immersing yourself in that world, and then as you immerse yourself in that world, it's a byproduct is that you will learn. And that's the sort of approach that I would like to take with our students. I don't think it's just children that are able to do that. I think adults are able to do that as well. And I think it's very powerful because you experience it. You don't just read about it, you experience it. And it's a memory that will hopefully last with you.
I think it's the difference between learning as memorization and learning as creating a mental model, right? So when you're learning, the best way to create mental models, to build intuition, isn't just to memorize stuff. It's actually to play around so that some of the variables of the model that you're working with, whatever tool or item you're dealing with, play around with it interactively so that the, how do you call it? So that the underlying model becomes something that you intuit, that you know and understand intuitively. And that's kind of the approach we're aiming to take with this course, really, so that you can start building an intuitive understanding of functional programming and of coding in particular. And we're still early days, right, because we're only targeting beginners for now, and the course we've released to our beta backers so far is really just for beginners. It's only for people starting out. And I think a lot of you experienced developers will find it a little bit basic, which is okay, because more exciting content will be coming in later sections. So that is that. So are we going to do some live coding?
I want to do some live coding. So
we're getting set up for a project, and then Mark will demo some live coding, which hopefully you'll find quite interesting. We're going to be trying some different spirograph stuff and failing a lot, which is kind of how you learn. So have we got a...
I'm just trying to reset my stuff. Oh, in fact, I want to stash it, so get stash.
Cool. We're also going through things that are not related to F#. For example, we've have several videos in the beginning of the course about Git, and that's because we kind of want to make sure that the tools that people are using are the right ones, and that they can support their learning in a useful way, basically. So what about the people here? We have a few viewers. Do you guys want to introduce yourself on the comments, or join us and start chatting in the group chat? We'd love to hear how you heard about us, and what you'd be interested in seeing on the course, and what's exciting about F# and how you've used F#. We'd love to hear from you. How are we doing, Mark? Have we got something? What do we need to do right now?
I need to get my Git to play ball with me.
It's origin, not origin. And right, master. What are you trying to? That's /master. Yeah. Your detached head, which is all right.
That's fine. Okay, so now I hope You can reload and create.
So yeah, we'll be kind of showing you some of the basically spoilers on the second section. When you're ready, I'll switch the screen over to you, Mark, and you can walk them through it.
No problem. No pressure.
No pressure.
Right, let me find this one. Bear with me, guys. I'm sorry it's taking me so long. I'm still adjusting to using a Mac, so that's why it's taking me so long. Okay, so where's it gone? Oh, it all seems to have gone piton. Let me try again.
Well, one viewer hanging out with us. Thank you. It'll get more exciting now. We didn't manage to get a special guest this time, but we will next time.
Yeah.
We'll get a special guest to join us on the Hangout. We can kind of interview him live and talk about his experience with FSharp. That should be quite interesting.
Have you got anyone in mind?
I don't know yet, but we'll figure something out. So how are we doing? Have we got...
I'm slowly getting there. I'm slowly getting there. It'll be worth waiting for, I promise.
Okay.
That's all I can say at the moment. I'm really sorry that I'm holding you up, but it will be worth waiting. Okay, so...
Cool. So as soon as Mark has got the editor ready, we'll do some live coding. Do you need anything else, or can we just recreate it from scratch?
We can recreate it from...
Have you got the spirograph thing? Can you just do a start here? Or?
Not yet. So just bear with me for a second. So,
okay.
And
news. In terms of news items, we're getting the website redesigned. That's on the way. Some of you have looked at it and said, "Oh my God, what is this thing?" So we've listened and we are getting it redesigned properly, so it'll look a little bit more professional, be a little bit more friendly. We're also currently working. I'll be spending the day tomorrow, for example, working on a platform. We're hoping to kind of be able to deliver to you a platform on which you'll be able to learn that will be integrated with FSharp in the backend. So you'll be able to try out the code examples live as the videos go on in the browser without needing to set up any other tool, so that you have an FSI available while you're watching the videos. That's upcoming. We don't make any guarantees, but that is something we're planning to try out. We have a couple of people who are helping us with that. To firstly put the infrastructure together so that we don't have to host all the servers, etc. And also with the interactive application, that's also going to be something that's coming in. So stay tuned for that. That should be quite exciting when we actually get it live, and the beta backers should be the first to get access to that. We're hoping that it'll be in beta by the time kind of fairly soon. So that the beta backers have access to it, and when it comes to general availability of the main course, then people on the main course will be able to have a tested platform in which they can kind of try FSharp code. So that's the plan. However, plans go terribly wrong all the time, so we're not sure whether that's going to happen or not. But that's definitely what we're hoping to achieve. How's that going?
Nearly there. Nearly there.
What's going on? What have we got?
I've got some Git issues, so that's why I'm going to
right.
because I was doing some coding last night and I went to bed without checking in and stuff.
Cool. So are you ready? Are you sharing your screen?
Let me just reduce the font size so I can actually.
Actually, big is quite good because the Google Hangout might be a bit blurry. So.
Okay.
So big is good.
I won't reduce it too much then. Cool. Okay, so let me
share your screen.
Okay.
So you'll want to go into Chrome, find the Hangout, and share the screen. Screen share, entire screen. Cool. Perfect. And once you've, yeah, cool.
Okay, so this is the code that I've managed to knock together at the moment. So it's quite rough around the edges. but it was taken from the logo book that I was reading. So that's why we've started to try and create a turtle. And basically, we started on the train when we were coming back from Sweden, and we wanted to prototype what we were going to be doing with the spirograph section. So we had a few issues trying to figure out how to plot some lines, and then we managed to find some algorithms on Wikipedia. One of the algorithms was a 1950s algorithm called Bresenham line. So we started to implement that and put that into action. And then we introduced a turtle to it so that we could actually pass a turtle into the function and it would manipulate the bitmap that was on the turtle.
The Bresenham algorithm is actually more of an efficiency issue. You can kind of figure it out yourself from base principle. Just try, how would I draw a line? It turns out there's a couple of things you need to do, but actually it's fairly straightforward. And we have a naive line implementation that does exactly the same line as the Bresenham. It's just a lot less efficient. So actually we'll be taking you through kind of the constructive approach to building a line, as well as kind of showing you an existing algorithm and kind of breaking that down. But it's an interesting exercise to do. Circles are pretty awesome too, the math you have to do for circles. There's a really great book called The Elements of Computing Systems. And at the end of the book, the last chapter gets you to, well, the chapter before last, gets you to draw a bunch of, I'll figure out a bunch of algorithms for drawing pixels on screen. It's highly recommended, The Elements of Computing Systems. So,
all right, let's create some nice, pretty pictures now. One thing to note is we don't have clipping added to any of the library yet. The reason being is because.
So what's clipping? What exactly is that?
Well, if you do anything to the graphics, you know that if you go out of the bounds of the canvas that you're drawing on, then your image will be clipped. So part of your image will disappear because it's off the canvas.
Mm-hmm.
So we don't have any of those capabilities yet. And I don't know if I will add any. It might be something that we'll pass out to some of the students as an exercise to see if they want to try and add some of these features. But we don't have that. So sometimes we can get some really nice errors. Let's see if I can reproduce one. So we get stopped due to error. That's because we've basically gone out of the area of the canvas.
What we're actually trying to figure out is that the cleanest approach to make invalid statements unpresentable, which is kind of the approach you should be taking with a strongly typed language like FSharp, is to make a statement that's incorrect. So any statement which has more than 500 should be a compiled error, not a runtime error. So we're working on this and trying to find the cleanest way of making that happen using ranges and restrictions for our types. So still something we're working on. We're hoping to get that in this section, although it might be a little bit steep in terms of a learning curve for very beginners. I think it'll be the right approach to teach that idea of really making incorrectness unrepresentable.
Yeah, I had a particular amount of fun doing this because as a young kid, I used to always watch my friends get all the best Christmas presents, and some of the Christmas presents they had were the spirograph sets. So I was happy to do this.
An actual hardware plastic spirograph.
Yeah, so you'd have these little cogs that you would put into a stencil. You'd have a pencil and some felt tips in different colors, and you'd be able to create these fancy pictures just on paper. But one of the things that always used to annoy me was that it was very limiting. Like after you'd done about 35 turns, if you'd had the patience to even get to that sort of level, you'd have a basic picture. I wanted to know what it looked like when you had thousands and thousands of turns. So this particular demo that I've got here shows how we can go up to thousands of turns. So how I've done it is I've got all my line drawings and all of the capabilities for doing that, and I create myself a set of instructions that I can then loop over and unfold them into an even larger list. So I generate this list up using the generator here, and then I use a take, and then I enumerate it to a list, and then I take 3,500 of them for this particular example. And then for those, I just append where I want to start my spirograph on the canvas, and then I just say go, and then save me a nice little pretty picture. So if we look now, I've just executed this one. If we look in the containing folder, we should have a PNG for the live session. So this one looks rather speckly, but that's essentially.
Do you want to zoom into that actually a little bit so that they can see that a little bit better? There we go.
That's essentially the sort of things that I'd always wanted to be able to see how it worked when I was a young lad.
A wee lad.
A wee lad, yes, as we say here in the UK. So now I've got myself a pretty little spirograph, and it was just like a bit of fun and games of just like tweaking a few of the variables and basically just playing with it. I mean, there was nothing really scientific after I'd managed to put the kit together.
One thing that is interesting though, in terms of the approach we took to build this stuff, is that there's a series of commands. So the underlying API to do image and bitmap manipulation is not functional. It's a very procedural API. You know, you change a pixel and that's what you do. It's a stateful API. And what we've done is actually recreated a not stateless, because we can't the underlying API being stateful is quite difficult. But we have created a kind of a command functions that create draw commands that get a stateful object and actually do the drawing of that particular command. And the idea being that these are much easier to compose. So we're composing commands instead of drawing pixel one at a time. And then once we have all the commands, then we can apply all these commands to a particular bitmap one after the other. So it makes our reasoning about our code much easier, and it gives us quite a bit of flexibility. Interesting aspect for the flexibility in particular is that if we wanted to turn a sequence of drawing command into an actual movie file, it would be the matter of taking the sequence of drawing commands, interspersing every drawing command with a save file with a given name, so save file as, and that would enable us to turn what is currently just draw an image into something that would actually draw an image for every frame of a movie, and then we could collapse the frames into an actual movie. So that's one of the flexibility that actually occurs when you're looking at an API and saying, how can I make my API stateless, so it's a purely functional API, even though I'm dealing with a stateful object for drawing stuff. So the bitmap object itself is quite stateful. In fact, it's a C#. It's not an F#. We're using the underlying stateful C# object. So have you got some more examples? Are you showing up?
Yeah, these are just little quick variations that I'm throwing together now, so you can sort of see how easy it is once you've got your library put together. One of the interesting things that I was speaking about on Twitter with Ross McKinley, if you know him, Pezzy Pink, you can follow him on Twitter, was to try and put it into something maybe like SDL and put some asyncs around it so we can actually animate the image as it's being generated. So that's one of the things that I would like to look at next, maybe, is to try and animate these images as they're being generated. So I think that's really cool. The
idea here would be to not for the students to do that, because the students would actually probably find it quite hard to kind of get to go through SDL as a separate idea. But the idea behind it would be to create a library for the students to use so that they can see their drawing commands, so they don't have to change anything from their current API to turn into something that can watch draw live, so that it actually draws in one by one. So we're still working on that. It's difficult, mostly because we were struggling to find the right cross-platform way of showing live drawing of an image that works across, Linux, Macs, and Windows. So instead, what we did is we just generate image files, so PNGs, which are pretty straightforward to generate across platform. And we're looking at SDL as a potential way of creating cross-platform visualization of the drawing commands, basically. So yeah, have you got something else to show us? Should we try and modify something?
I think this is like pretty boring now because like I'm only showing certain variations of the same thing.
Right. So let's create something else instead of creating spiragraphs, right? Let's let's compose some stuff and let's create tessellations, for example.
Let's open up a new file and let's play with some of the other bits that the library can do. Cool. So I'll create another little script file here. I'll copy some of the stuff that I've had from here so I don't have to re-type it all out. And we'll play with some of the logo things that I thought was quite cool.
Yep.
So I'll copy the save.
You should have all that as commands somewhere else, right?
Yeah, should do.
Okay. So we're not hearing much from you. If you're watching, do let us know either on Twitter or in the comments or in the group chat. We'd love to hear from you. Ask us questions. Let us know what you'd like to see, and we will definitely get onto it and give you the content you want. So definitely get in touch. So yeah, so we now have a turtle, which is this is kind of the basic turtle. We're creating an hexagon basically. And you'll notice this pipe character that we're using. You could equally, instead of piping one after the other, you could have that as a list, manipulate the list, and then reduce over the list.
Got everything.
So do we have an image?
I don't think so yet.
Okay. Live session. Has live session not changed?
No, not because it's not saved. Always happens when you do it. The demo fairies always come out to get you.
The demo fairies.
I want to see what other people have done. Is there anyone actually listening that has done any of the videos yet? And what do you think of the videos? That's what I'd like to know, because I'm quite anxious to get some feedback, really.
So how are we doing?
Not doing too well at the moment. Let me take this.
I'll let you.
Let me have a bit of time there.
Try and sort that out. So yeah, so we're building this logo library, I guess you would call it. And what's coming up after the logo library? So after the logo library, we're going to be looking at data types, from what I recall correctly. We're going to be looking at type providers and grabbing data from a, let me find the exact word. So grabbing data from the World Bank and grabbing data from the WHO, so the World Health Organization, in order to show people how to use type providers to manipulate data. So that's the kind of the idea that comes after we've kind of played around with our turtles and creating graphics. The next bit is, how do we grab data from a place, from a useful place? In our case, we're going to be looking at statistics from the World Bank and the WHO, and how do we get those to kind of make sense, really, from your programming language? And from a beginner's point of view, from an experience point of view, you're just talking to an API, you're grabbing a file and using an interface. But one of the things that FSharp does really, really well is actually give you the ability to inspect something while you're in your editor, press dot, and then autocomplete on live data, which is something that is really hard to do in any other way but with type providers. So that's a really wonderful feature, and we'll be exploring that in a lot more depth in the third section of kind of the core course that's coming next. And that'll be part of the main course that's going on. And in addition to that, once we've got the processing data, we'll be doing web apps, which is actually going to be taken over by Henrik. Henrik will be doing the web app section for using Suave. And finally, we'll be doing the professional stuff. So if you're interested in any of this stuff, then let us know, pipe up, give us a shout on Twitter or on Google+. And that's kind of the progression we've got planned. How are you doing, Mark?
I'm slowly getting there. So
Okay.
yeah, just bear with me again. Sorry.
Okay, cool.
Sorry, guys.
We're also going to be working on, in parallel, on the NoSQL course. So the NoSQL course is basically building your own NoSQL database. And we have quite an interesting plan to do that, because we're kind of planning to go interface first and see what happens. So there's a lot of really interesting stuff to do with data structures when you're talking about a database, especially persistent data structures. So how do you persist them into disk? That's something that's very interesting. And we're slowly trying to prototype this up. But the first thing we're going to get our students to do is think of, how do I call? So what's my interface? We'll be creating a web interface from the start for the NoSQL database. and then building on top of that to create, I'm not sure what kind of database it's going to be yet. We haven't made those decisions, and we'd be really interested in seeing what you're interested in. So there are many options, and currently the two big ones are either a simple, like a key value pair database, or a graph database. One particular type of database I'd quite like to see is an append-only triple, or like a RDF triple database. So RDF triples are basically entity relationship value pairs, or triples rather than pairs. It's really interesting because you can build a very sophisticated data structure with just those links. So essentially, you're creating kind of, it's not quite a graph, but it's almost. And creating it append only gives you a lot of really interesting properties. Another database that does that very well is called Datomic. So Datomic has a very interesting read and write model, in that every write is channeled through a single writer. However, reads are completely distributed. And not only are reads distributed, but the data is distributed too. So there's a single point of write, but the reads are distributed, and every handle you have on the database isn't just a handle on the database, it's a handle on the database at a particular point in time. And essentially, you can query the database and say, I'd like to know X, Y, Z at this point in time. And it will give you the state of the database. That's really powerful for things like auditing or analysis or anything like that. And the idea is that you're not changing immutable values stored on disk. The database doesn't let you mutate. It's an append-only database because you're basically stating a fact. And facts don't ever are never incorrect. They are outdated at some point in time, so they are replaced and deprecated, but they are not incorrect when you actually store them in your database. And that model is something that's really interesting. It gives you lots of really interesting properties. In particular, the current state of the database is basically reducing with a merge over all updates. So it's really a powerful model for reading and writing data. Really can give you a lot of benefits. And maybe that's an avenue that we'll look into to kind of show you some of this in the NoSQL database course. So that's something interesting to look forward to. How are we doing with the live coding? Have we got something going?
I think so. I think I can give you a small demo of.
All right. Should we switch over to your screen?
Go on, do the switch over.
Okay, let's switch over.
I'll put you out of your misery. So I just want to show you the logo functionality now. So it's still obviously in prototype, so it's not like a polished product or anything. But we've got the ability to turn and move. I haven't added the pen up or the pen down functionality. We've ever used logo or turtle before.
Well, why not create it?
Well, we can create it. I wouldn't want to tempt the demo fairies tonight. I don't feel confident enough to do that.
I think we should. I think we totally should create the pen up and pen down.
You're a hard taskmaster, Reese. I'll show you how to do the pen up and pen down. Okay, so we've got the image on the left of the screen. If you can see that, we've got one line that's going around 45 degrees in red. And I want to show you how you can turtle and do some other really cool functions. So I'm going to add some code now so we can see the turtle move. And let's see how it looks now if I add that command so you can see that it's actually working, hopefully. So if I click on there, now we've got some movement happening, right? So it looks like it's working. So let's add some more little functions to this. Let's turn 45 degrees and move 90, and then see how that looks. Okay, so we've got some little things going on here. Let's go to the spirograph then, and let's see if we can tempt fate and add a pen up and pen down function. Don't know why I let him talk me into this.
So, I mean, the idea of the pen and pen color is really the turtle is, we've kind of created a stateful turtle. Well, it's not a stateful turtle, it's a value, right? The turtle is basically a value. And we're creating new values as we go down all these drawing commands. And every time we pass through a drawing command, we're creating a new value. So the idea is that a drawing command takes in an image and a turtle, or really a turtle that wraps an image, and returns to you a new turtle and a new image. In practice, because the image isn't, we don't want to duplicate images every time, we're using the same image, but we are recreating the turtle. So every time you're passing something through, the command takes in a turtle, returns a turtle, and the turtle has an image. It also has a direction. the state of the turtle at any one point is given by the direction and its position. And then you're drawing relative to that particular turtle. So that's the idea behind the turtle. It's a very simple idea of kind of putting all this inside an object and then passing that object as a value between your function, your drawing functions. But it turns out it has some really useful property in terms of how do you call it? In terms of composability. It's much easier to compose something once you've created this kind of this value object that you're passing between functions that transform from one to the other. So that's the idea behind the turtle type.
I'm going to add some little things to this. This is very hacky, so please bear with me. But I'll add a Boolean value for whether pen is up or pen is down. And basically, whenever the pen is up, when we try to use the move command, we don't want the turtle to be drawn or affected. So I'm going to check here within the move function that if our pen state for the turtle is up, so if it is up, or if it's not going to be drawing, then it won't draw this. So the pen state will have to be true for it to draw the turtle.
So pen state is actually, I'd rename that to something more explicit. So turtle is drawing or turtle something else, so that it's a lot more explicit.
Okay. So
that it reads better. So you can say if turtle is drawing, then draw. If
let's do this. So is drawing.
What do you think? Is that a good change of name, or the old joke, right? The two most important problems in computer science. Naming things is number one. Number two is cache invalidation. And number three is off-by-one errors. I'm getting no laughs whatsoever from Mark.
I'm not,
clearly the joke fell right.
I'm not smart enough to get your jokes. That's what it is. Oops. In fact, I think something a bit more naughty went on there.
So cool. So for those of you joining us now, we are live coding some stuff with our examples from section 2, where we're creating a turtle to reproduce kind of the ideas behind logos in F# to teach some of the beginners to appreciate composing functions and using abstraction. The key takeaways really is how to take small components of functionality and turn them into big ones through abstraction. And logo seems to be one of the most visual and engaging way of doing that, because you've got a visual output straight away. And that's the idea, basically. How are we doing? What's going on?
I think I would like to say I'm done. We'll find out in a second.
So can you, for example, put the pen up or put the pen down?
I will try and do that.
Do you have pen up and pen down methods?
Almost. All right, so let's add some functions for pen up and pen down. So let pen up, and we shall say turtle.
Yep.
So that's what we're going to take in, and then we're going to feed the turtle back out again. So what we need to do is we need to know whether the turtle is going to be drawing or not drawing. So drawing state, I guess, is one of the things we could feed into it. What do you think about our name there, please?
No, we just turtle and a turtle.
You want a turtle?
We just say pen up. We get a turtle, and the turtle return a new turtle with the state of the pen of is drawing being true, or false for pen up. And yeah, and that's it.
And pen down. Pretty much the same stuff again, but just the opposite.
Yep.
Cool. If you've seen this before, you probably have seen it many times. They use an AST. The reason why we've used the raw functions is because we don't want to introduce people to how to build ASTs yet. Build functions, no matter how rudimentary those functions may be.
So the idea is, like, for example, another person who uses logo as a educational tool is Phil Shelford, and he creates a specific language in F# using fparsec to be able to parse a logo-like language. But we're using similar ideas, but we're not using a special language. We're using F# directly. We feel like we should be teaching the language that they're going to kind of go towards as quickly as possible, especially since we have a mixed bunch of experienced and non-experienced developers. So that's kind of why we made the decision of creating something in pure F#. So we're creating a domain-specific language in F#, if that makes sense.
So hopefully I've got this correct now. So if I execute this,
yep,
it should now remove one of the lines that I've recently added.
Yep. Yeah, it does. Perfect.
So if I shift that around, we should see some other little interesting things, hopefully.
So what that could do is now, can you create a dashed line? Could we compose pen up, pen down, and move to create a dashed line? How would we do that?
We'd create ourselves a little function and then feed the function into here.
Don't tell me, show me. So let's have it up.
Okay, so we've got ourselves a move function. So let's move 45. Let's remove some of the stuff beforehand.
Well, why not create a new function that says dashed line that has the same API as line or write or whatever the other one is called, and or move dashed or something. And that will take a value, but instead of using the value, it will kind of break it up into separate pen up and pen down. So
as you're speaking, I'm doing.
It's not going to use a new turtle. It's going to be past a turtle. So it's a function that we can compose afterwards. It's not going to be a new graph. So yeah, so like very much the ideas behind some of this stuff is that I can compose these ideas of create a dashed line. We'll also be thinking about how can we compose ideas to create thicker lines. How would we do that? What's the idea behind that? And when you have a rectangle, can you create a rectangle, a filled rectangle that is, into a how do you call it? Into a thick dashed line? Is that possible? Those are the kind of the question that we want to ask our students as they create stuff. So dashed line is going to take also a length instead of before the turtle. So it's going to be let dashed line length turtle.
I thought I'd do just 45 at the moment, but we can change that.
Because that's not okay. Let's try that.
So we can duplicate that one many times, and then we can do some recursion on that. Oops. Doesn't seem to want to play ball with me.
No, I think you're going to have to repeat that more often when you're doing the dashed line.
I think it's just from the angle
and you'll
you
need
start
to, yeah.
So turn 130. That would be better. So what angle is that now? Okay, so now we've got ourselves one of those, and we probably need to pen down again. And that'll do it. So do it again, same thing again. And now add. Why is it not working? I have no idea why it's not working.
Well, it's pen up and pen down. Pen up should be working, right? And pen down is working as well. How would we create a nice logout function that prints out the turtle parameters? That'll be a really useful debugging tool. So let's create that, I think. That's something that just debug, just prints out the turtle and kind of passes it on.
Turtle.
Magic, and then turtle.
I don't know if this is going to work yet, so don't.
Oh, you need to return the turtle as well. Cool. In fact, we could just put print. No, I don't think print is passes its arguments back out, does it?
No, it returns a void, a unit.
No, I was thinking of putting it in the dash line, but okay.
Okay. I don't think this is going very well. If I only had time to sort of prepare some of this. All right, I think that's enough for now.
No, let's just try and figure this out. We've got a turtle. We're moving stuff around. It's definitely moving, but it's not going pen up and pen down, right? So let's try and debug it. What's happening between turtle and move? Let's print the turtle before we move. Then let's print the turtle after we move. Let's print the turtle after pen up, after move 45, after pen down, after move 45. No, I mean like in the dash line method.
So turtle is direction 30, is drawing, the position is the same.
Inside our dashed line, can we remove the print turtle from the clipping example and move it to inside our dashed line between move, pen up and move?
Yep.
And let's remove the print line from the clipping example. And add a print turtle before pen up. Cool. Let's take a look. So what's actually going on? It's doing exactly what we're expecting. What's going wrong in our expectation? It's always the case that when you've got a bug, it's because you made an incorrect assumption. So we're assuming something that isn't so. So what do we assume?
Okay, so we start at position 184, it says.
Yep, and it hasn't moved after pen up, which is correct, but has the pen changed? Yes, it has. Isdrawing is now false, which is great. Then it does move 45, which definitely does not move. Does it move? No, it does not. So it hasn't moved. So why is it not moved when you do move 45? What's wrong with the move?
Because the function that we've written is too tightly coupled. So we've got a function that draws a line.
Well, let's just take a look at move, right? Move used to work and it no longer does.
Yeah, because this function here, draw line, does more than just draw a line. It moves as well.
Right. So how would we split those two responsibility? Well, actually, why not just move the responsibility to draw line? Draw line takes in a turtle, right? So let's move the responsibility whether we draw stuff. And let's change the name to move.
I think I need to remove that bit first so we can bring that back in. So it's doing what it was doing originally. And just move it closer.
Yep. Do you not have a move to?
I do, but it's a different kind of function. So we've got our line function here, and we move because we've got our turtle there. So what we need to do is, if we're going to move, is not draw the line.
Well, no, I mean, we can just, yeah, absolutely. Yeah, put everything in a... No, scroll up. wait, so let's take a look at the resonance function, the bottom of the resonance function. Now we have a bunch of set pixels, right?
Mm-hmm.
And a recursive call to an internal function called draw. Well, the only thing we really want to avoid is drawing. So let's say ignore drawing if we're not supposed to be drawing. So turtle.isDrawing, then draw. Done. Save that, and that should work as we expect, I think. If it compiles, it works, right?
Most of the time.
Here we go, and a dash line. I don't know how well that comes up in Google Chrome, but we definitely have a dash line. Can you leave it on the dash line for a little bit more? Here we go, brilliant, perfect, cool. So let's generalize the dash line function so that instead of having just being 2 dash line of 45, let's give it a length parameter, and then we'll be able to create a dash line of any length, and then we'll have a length parameter, and the second one is the length of the dashes, and the next one is the length of the empty spaces. I don't know what you'd call it. Right, so that's the length of a single dash. What I'd like to do is not do that, because that's the length of a single dash. I'd like to pass in the first length of my dash line. Should actually be the length of the entire dash line, not just a single dash.
Oh, I see what you mean. So not the gaps. You want the
exactly.
actual,
yeah, so we'll need to divide the length of the line by, well, we need to figure out how many dashes we need. Then we'll need to repeat the individual dash empty dash and then empty space n number of times, depending on how long is our entire line. So let's start with a fixed dash length and just do let dash line length turtle instead. So we don't want dash length. Can we get rid of that name? That's the wrong kind of name. So for the right. So we can definitely do move dash length then on line 11. Instead of moving length, we'll move dash length. We haven't defined it yet, but that's okay. We can do that later. So in fact, let's put the pen down. Let's start by putting the pen down, right? Because we want to make sure that we're drawing a dash line correctly. So putting the pen down, then moving dash length, then putting the pen up.
Yeah.
And then moving the dash length, and then putting the pen down. Great. And then we can remove all the rest. No, let's just remove line 11 to 20, 15 to 20. Cool. So now the idea is we want to be able to repeat this. How are we going to repeat this multiple times?
You could use the for. So we can create a for and do that.
Yep.
So let's repeat. Let's call it that. Equal for I in 1 to 10.
Well, we don't know what that's going to be, right?
Not yet. We don't know.
Right.
But we know how long the dash length is going to be, right? Don't we?
We do. Let's let the dash length equals to 5 or something before the function begins. Before we start using it. So maybe on line inside the dash line function, it's on line between line 9 and 10. Cool. Right.
And so this one is going to return us a nice turtle, yeah?
Yeah, I mean, we have everything we do has to return a turtle. Okay. So what might be quite interesting is to have a sequence of commands so that we pass the repeat, and then that simply repeats the sequence of command n times, and then returns the turtle. That could be an interesting one.
So if you take what I did earlier, we just put our dashed line in here.
I'm not quite sure where you're going, actually.
Well, we just want the dashed line to be repeated many times. So if I do what I did,
well, actually, we want pen down, up, and pen. We want the sequence of command inside the dash line to be repeated multiple times.
Okay, and
so I'm not sure where you're going.
I thought you wanted to generate some commands from this single item and repeat it.
So what I'd like to do is turn pen down, basically line 12, 13, 14, 15, put those into a sequence, and then repeat the sequence as many times as appropriate for the length of the dash line that we specified in the function. So we have some sort of, instead of having piping orders through the turtle, we have those inside a sequence. So we definitely want to keep them. Yeah, cool. But we just put them in the sequence by removing the pipe characters. We don't want the turtle though. We don't want the turtle in there. Cool. So now we've got a sequence of four commands, 4 drawing commands. And we want to reduce over that sequence so that we pass the turtle in as the initial value and execute the command against the turtle, and then to give us our new accumulated value.
So you want to take turtle in, yeah?
No, I mean, we can, there's a fold, right? There's a fold function.
So list fold.
Cool. So we want to pass in the, I can't remember the ordering of the arguments, but I think it's, what's the first argument?
State, and then you've got the...
So the state is going to be turtle.
Mm-hmm.
No, wait, will that work? That should be the last argument, right? Not the first one.
Yeah, it's fine.
So it's list.forTurtle, and then we pass on. We'll need to give it the reducer function. Fold. Here we go. We give fold a folder, a state, and a list. That's great. So the first thing that's going to come is the function, then the state. So it's the turtle. Yeah, great, awesome.
And you want something else, don't you?
Well, that's going to take 2 arguments actually. That's going to, the function here is going to take 2 arguments. It's going to take the, I can't remember what the ordering is.
So you got the state first, and then you've got the
inside the reducing function.
Yeah.
Cool. So the state is going to be the turtle.
Yep.
And the next one is going to be the command. So you've got I. All right, cool. And we want to return the command applied to the turtle. Although I seems a bit strange now.
Yeah.
Command probably. And we want to pass that the turtle in next, right? Into the fold.
Yeah.
And that we'll need a turtle, and what else will we need? The list. So we'll need to give a name to our command list. And we'll need to rename the command list.
Where?
Between line 12 and 15. That's our command list.
Okay.
but we want to do that inside the dash line function. It's going to get interesting because the length is not like the length of the entire dash line is not necessarily going to be a multiple of the dashed list or of the dash length. So that's going to be a little bit more difficult. But let's start with that, right? And then we don't want a reducer here. We don't want to let a value reducer, right? We just want to return from dash line the fold or the total of the commands. And the idea is that we can repeat this command list as many times as we want. Is there a repeat function in, or cycle, it's sometimes called, in FSharp?
I just ended up generating my own commands by taking a number of items from my generated list.
No, but
so I unfold it.
Right, unfold, right? I guess that's the kind of the same as repeat. So we want to do that inside our dash line, right? So talk me through the unfold function, actually.
The unfold function is a way of generating a list of things, making your thing a lot larger than what it is, so you build things up from it.
Yep. So I'm doing some looking at cyclic lists in FSharp. See whether we can create a cyclic list and then only take a number. So cool. So you want to try and work on that unfold to generate the bunch of dashes and dots, and then see what we can get.
Okay.
The idea is we can repeat this drawing command, right? Infinite sequence with repeating elements. That sounds promising. While true, do yield 1. Ah, beautiful. We can actually create our own repeat function, which looks quite nice. If we create a generic repeat function in the seek module, that could take us where we want to be. How are we doing?
I'm still trying to figure out.
We've got a lovely recursive effect going on in our screen right now. Just have a look at this this right now, this thing here, this seek. Let repeat items equals, in fact, let's just define this thing here, right? This is let repeat items, which will take in a sequence and return a repeated sequence, and then we can take n from that sequence. So if we find out, where are we now?
Let's just try out my other front.
So if we just create that repeat, let repeat items equal seek, this thing. There we go. So that will let us repeat in a sequence infinitely, and then we can take an appropriate amount from it. Now, as an exercise to the watchers, how would you create a recursive function that only uses first and rest to create a repeating sequence, an infinitely repeating sequence? It's actually quite an interesting problem. It's actually quite fun. So if you take in a function that, and your only building blocks are get the first element, get the rest of the list, how would you create a repeat infinite function or an infinite list? So we got this repeat. Cool. Yeah. Do you want to load it into the FSI and have a play around in the FSI just to check it's working as we expect it to? So take some stuff from a seek, something like that. Oh, we'll need to take something, otherwise I think it'll do infinite.
It's gonna keep doing it.
Yeah. So should we take 5 or something? Five from a list of 3 and see what happens?
What do you mean? I'm not actually sure what you mean, to be honest with you.
So how do we take, say, 5 or 7 items from
You just do a take. Like,
right. Well, let's take 5 from repeats 1, 2, 3, 4 or something, or 1, 2, 3. So we'll need take before we use repeat, right? Yep. But take will need repeat will need a sequence. You'll need to give repeat a sequence. So give it a range of 3 or something. Oh yeah, we need to load that up.
What I did. Oh, I think my session reset, isn't it?
Yeah. Cool. That's interesting. It's I think it's understanding it's an infinite list, right?
Yeah.
Nice. That's quite a nice feature. Didn't know that. So cool. So we have got this take thing, right? And we've got this repeat. So when we move to our dashing code, let's create a repeated sequence of dash and up and of dashes and empty spaces. Let's remove this command gen stuff. No, why don't we just add it straight into the?
I'll try.
But we don't know when, like, we don't know what dash length is. It's not. This isn't defined in the function that we're trying to create, right? We're trying to create the dash line function instead of command list. Let command list equals repeat and then this stuff, and then we don't have to define it twice. And then how many we take will depend on the length of the dashed line, right? So we can remove line 20 to 23 and say,
you don't need that now, do you?
Well, we will, but first let's change the command list to be repeat. Just put repeat before the actual list, and let's figure out how many we need to take given the actual length. So what's that's going to be the length divided by 10, right?
Yep.
So let's do seek.take length divided by 10. And from what I understand, that should be integer division. So it'll floor, it'll be equivalent to rounding to the floor, which should be exactly the behavior we're looking for, right? Awesome. So that will take the appropriate number of dashes.
Yep. Okay.
And now we want to apply them, and that should be done. We should be done now. Obviously, we'll need to return the total at the end, which we're not doing right now. Are we? Yes, we are. So remove total on line 14. We no longer need total on line 14. Cool. Does it compile?
No.
No. No, of course not. This value is not a function applied. Where are we looking at? Where's the error?
1528.
15 and 28. That's interesting.
Ah, it's the indentation.
Right, it's the indentation. Okay, cool. So let's fix that.
I'm just going to cheat here and put it all on one line. I don't normally like semicolons, but in this situation. Tighten this up a little bit.
Right, that looks pretty good. That's actually fairly readable.
Oops. 17, take the... How long do you want the actual length here? We just want this to be.
That's correct. I think that's the exact one. I mean, if it's what, I'm not sure what's going on here, but why is it? What's the error? What's the type? I couldn't see that.
Type is
I can't see
the
type
int
error.
does not match the type generic A to SQL for generic B.
Why would it? All right, I'm not sure what.
I'm going to put it.
Okay.
I don't know why that is doing either, to be honest with you.
So I'm not sure what the. I can't read the type error from here. So.
So once it's because we're doing with seeks. No.
What's that? I can't see what's going on. I'm not quite sure.
It's because I'm using the wrong types. Because I'm unprepared. Sorry.
Right. So seek.take line length. Why would that give us a problem?
Because it's expecting a turtle to be in the type of list rather than the type of seek.
Why would it be expecting turtle to be in the type of list? Right. So I can't. So this expression expects us to have A to A list, but it has type sequence turtle to turtle. So it has a sequence of turtle to turtle instead of that being a list of something of methods. Is that correct?
Mm-hmm.
Right. So it's not list.fold. It'll be seek.fold. There we go.
Did this work or didn't it?
No, it didn't. Just got a black screen. Can we go back? Can we make sure? Could you do me a favor and move the Finder window to the same screen as? Oh, you can't. Okay, fine. So cool. So now we have this dashed line, right? We're doing 60. That should be divisible fully by 10. Repeat down, move dash length, pen up, move dash length. So you can obtain line length. How about we print out what command list looks like at the end? On line 18. Let's print out the command list. I'm hoping it'll be pretty printed.
I hope so too.
So let's take a look at this. Where is it? So let's remove the other. Yeah, let's take a look. What have we got? Clipping example. Dash line, turtles, paragraph, turtles, turtle. I'm not sure where it's printed.
There. I think that's what it is.
Ah, okay. Should that be empty?
I don't think so. I think it should be full of 60 commands, right?
Yeah. Or
Or
6.
Yeah, 15 or whatever it is.
Yeah. So we've got an issue here, right?
Yeah, I'd say we do.
So what's line length?
So line length, yeah, okay, let's print that one out as well.
We've lost most. That might be good to put some. Anyway, that will be a problem, right? So why is line length 0? Why are we passing 60 but getting 0? That's the problem.
You're not. You're dividing 5 by 10, right? So
that's not dash length I want to divide. I want to divide length by this thing. That'll be why. Right. Cool.
And before I do that, let's make the line smaller first.
Sure. I shouldn't ever go beyond that, so I don't think that should be an issue. No. Do me a favor and moving the Finder to a different desktop so we don't have get out of the back screen.
Try to find it to a different.
Yes, please, because right now the recursive effect is mind-boggling. Find out. Right, cool. So let's take a look at whichever one we're currently on. Which one are we creating? Where is it?
Yeah.
Logo pick, right?
Yep, so there's nothing there at the moment.
Right. I think if you double click that and open the Finder, then you'll find that you no longer need to. Can you escape that? Can you? Yeah, great. Great, cool, that's good enough. So now we have this logo pick thing, we can just jump back to it and it should update as soon as we've got it selected. Great. So what's the issue? Why are we not writing stuff, right? So let's draw a single line before we start messing around with anything else. Inside our turtle, let's draw a line symbol. Well, that would be our reason why.
Okay.
So I really like to get this dashed line working before we call it a night. So let's figure out why this is not working. Are we, so firstly, let's remove all the printing stuff. If we can, we're printing a bunch of, so not in online, not those ones. The other one that prints out the turtle, print turtle, is used somewhere else, or is it not?
No.
Okay, I guess that's just a turtle value that's printed out automatically. Cool. So let's figure out why simple line it doesn't work right now. We're not even trying to, we just do moving. So let's do a pen down before we move. Let's make sure that the pen is down by default. All right, jump back.
Should have been there.
No, it's not. Move to is the one that doesn't draw anything. So now we want to move, turn 180, turn 30. So absolutely, now we've got a problem with move. Move isn't doing its job. So
I think that's because what we did in the
let's take a look at move.
FS. It's this here, isn't it? It's the is drawing.
So if we remove it, does it work?
Yes, I'm pretty certain it will.
Well, let's test that assumption. I think that's an incorrect assumption.
Okay.
So it's not dash length, right? We're not calling dash length at all. So that's not changing anything else. So we're only using move. So let's just move to, and this is why we are turning 180.
So we don't, when we move forward, we don't move off the top of the page.
We should be at 150 coordinates, right? So that, I don't think that should matter. So let's get rid of that as a potential problem. Cool. Right. I don't think that looks like it's anywhere on there. Cool. So we do pen down. So let's make sure that the assumption about pen down being down is correct.
Yep.
Actually, it's one above, but yep, cool, that looks good. So pen down is good. So move is now broken. Somehow move has been broken, right? So let's figure out what went wrong with move.
We have not changed move. The only thing that's changed is the draw line. So the draw line uses the Bresenham algorithm.
Have we changed anything in line 19 that wasn't like that before? So that was what's going on there. Have we changed anything? Did we just add a new line?
I don't think so.
Okay, cool.
Just a new line. Yeah. I think it's just our functions. I don't think there's anything wrong.
Why is there an else? This else turtle. Let's just stay draw line, right? Draw line turtle. Yeah, cool. Save that. Yeah.
I think it's just this function we've got just doesn't do what we think it does.
But we're not calling it at all right now. So we should still be seeing. Let's try and draw a square, right? Simple, silly square. Let's do a draw 30, move 30, rotate 90, move 30, rotate 90 in here. So just check that way. We can draw a 30 by 30 by 30, well, 30 by 30 square. We can get rid of that. Right.
Nope.
Are we, is the color an issue? Are we drawing the wrong color? Are we not passing the color to something? Does movement
from the other ones,
require
so
color?
they still work. Ah.
I think we're just not setting the pen color at all.
No, it's not generated.
What do you mean it's not generating?
That was a preset that was already there, so it should have been working.
So I'm aware we're over time now. It's about 8:15, but I think I'd really like to get that sorted. At least to get us back to drawing something, right? That's going to be a syntax error. There's a syntax error on, yeah.
I don't know what to do, pretty much.
But we should be able to find a diff of the changes, right?
Or you can just do a git reset if you want.
No, let's try and figure this out. Which this is.
Right, so we've got our repeat.
Right, we can ignore repeat. That's just a function. Dash line is just a function. Let's ignore those. Let's make sure we can. Oh, this command gen. Let's get rid of that entirely. Right. Let's ignore the functions. Does it? Can it compile firstly? Or we got type errors right now. No, we've got type errors. So let's get rid of the type errors. Logo 16.
Let's get rid of all this dash list.
Right. Compile it. And yeah, move. Yeah. Right.
That's my image.
Yeah, it can. Right, here we go. Much better. So now we actually have a line on there. I don't know whether you can see it on the Hangout, but there's definitely a red dash. Avoid the black screen. Yeah, here we go. Cool. Can we get out of there? Yeah, cool. If we jump back to our editor, right, let's uncomment the dash line, right? Right, save, make sure that's not something stupid with the line indentation. Can we fix that indentation?
Do it on one line, and you can be sure. Get rid of that.
Well, just save commandless instead of doing it. No, just leave that. Right now, instead of doing it for an arbitrary length, we're just having one dash. So go back to just make sure that runs as appropriate. We're not changing the code. Right, what's the here? That's because it's not list.fold, it's seek.fold. not compatible with that, seek unit. Total command total.
What's this doing?
Yeah, let's get rid of that. Might try and rerun it. Right, great. Do we still have a dash?
No.
Click on it. Okay, so why do we not have the dash? How is this affecting the rest of our stuff? Right, that shouldn't be affecting the rest of our stuff at all, right? We're not even calling it. So there's an indentation or error here somewhere. We're doing something stupid. So what are we doing that's stupid? Can we look at the indentation? Can we make sure that we've done something right? Can you just return the total at the end of dashed line? Right, can we click on that instead of just going to it? Yeah, okay, go back. And if you just comment that bit of code out, no, the entire thing. Right.
So it's not that. I think it's the seek. This seek here and the repeat. Maybe it's just dodgy bit of code.
No, this is pretty straightforward, and we're using it, so we're going to get a type error if we get that.
Not yet. We're not using it.
No, I think just close that. Basically, delete that logic pick, and every time, yeah, right, cool. That's the problem. It's because of the preview not being correct. So can we do one thing? Move this window outside of this recursing thing, because that's, I'll just change. Yeah, cool, great, awesome. Right. So can we make sure that we open it up every time, basically? So if you go Alt Command Space, that should open up a Finder window. And awesome. Right, close that. Let's jump back in. So close the preview. Right, jump back. Let's uncomment some of the stuff we've been doing. So firstly, the dashed line, just that. Right, let's take a look at this file. Open it up again. Right, great. Let's jump back. I'm willing to bet it's purely a Finder issue. Yeah, it's examining. So now uncomment repeat. Looks good. Great. So now we've got repeat. Let's repeat that command list and take the appropriate amount from that command list. So instead of doing it here, why don't we keep the command list as an infant sequence and use it on line 17 so that it's a lot clearer to read. So I think you can just do seek.take5 command list, right? Instead of 5, it's going to be length over dash length times 2.
Sorry? I thought it was length over 10 you did last time.
Yeah, same. Cool. And let's make sure that we save that in a variable. So dashes or something. Oh, not variable. I'm going to be lynched if I say variable. It's a value. And then we can fold over the values instead of the command list. Cool. Now let's try and write a dash line then.
Okay, cool.
And then move 60 and maybe dash line 60. Yeah. This value is not a function and cannot be applied. Like 17.
You want that first, right?
Just put around length.10, I think, right?
No. C.take.
Takes an int, yeah, and takes a list, right?
Yep. What's this one? Should look like it has type turtle. I need to assign that. What have we got this here for?
Cool.
No. Oh, it's just going to break again.
We're getting more interesting errors now. So why is it breaking now? What the hell's going on? It's not giving a type error. It's not giving anything. It's just completely.
I've done something foobar with this thing. Any suggestions would be greatly appreciated. I know most of you guys watching are MVPs for F# anyway.
So I see .fold, right? So that's what's going on. Where's the error? What's currently causing the error? No, that's.
I'm sure it is. That's what we want.
Correct. That's absolutely what we want. Yeah. So can we remove that? Well, we can leave the X now. But if we try and run it, why is it giving us compilation errors? And what's it throwing a debugger error? That's very strange. Can we just try and run that again? Reset the FSharp interactive. And, right. Right, so paragraph.fs is causing an issue. Jump back. Something's wrong with paragraph.fs. It's gone really, really wrong.
It wipes out the message.
But that's something else. Something weird's going on here. So let's open that project up again. Cool.
Yeah, let's have a look at that one now. If it was...
Can we just run it? Is it just a weird build issue?
I don't think so.
Right, let's read this carefully. Require command line developer tools. So LLD, what's actually going on? SIG abort while executed native code. So let's read what the actual error message is. It's quite long, so let's read what's actually going on here. So we've got a very, very long and complex error message from something we've done. Assertion saying point to null not met stack trace. Right, that's wonderful. We're getting something to do with null pointers. So when does it trigger this long error?
Dashed line. Okay,
so dash line does something weird, right? What would it do weird? Instead of length over 10, so let's what's going weird in there?
Try smaller command list maybe?
No, I don't think so. I think that shouldn't be meta. Something to let's just comment stuff out until we find the issue, right?
But there's okay. Let's do that first of all. Let's just return turtle.
No, let's try that. Right, that's looking good. So it's in our fault. What's wrong with our fault? What's going really, really wrong with our fault? That we're getting thrown into the debugger.
Okay, so what is the fault actually doing? It's taking our command list.
So let's take the length of dashes to right. That should be fine. Turtle and command and applies command to turtle. Yeah, that looks perfectly good to me. It's not the renaming of turtle that shouldn't matter, right?
I think so. Maybe we can just change that to T.
I'd be very surprised if that was something stupid.
Yeah, me too. Let's just change that on there too.
Right, that's more like it. The unit does not match type total.
That's because that on there is returning.
That's more that, but we're not getting weird errors anymore. This expression has value. Just go back to that error. We had a type error when we're on top of it. Stack Overflow. That means the command list is infinite. I'm getting a Stack Overflow error in unmanaged fault address. That's, I'm guessing. What's the length of
Let's take 40 from here.
Right, let's start with that. Right.
No.
Okay, so let's take a look at why is our seek.take doing something weird on command list. So is it command list that's actually trying to, no, that should be fine. That was fine before. So what happens when we take, when you actually take it on the command list itself, or pipe it into take instead? So if we pipe the seek.take, like we pipe the repeat into seek.take 40 or something.
Command list into here. Yeah?
Well, no, I mean like move seek.take up to the end of line 16 with a pipe.
No, or you want? Oh, yes, you mean. Sorry. Yeah.
Yeah.
It's an indentation thing. Dashes not defined.
Right. That's because it's going to be command list.
Please work.
This is an object using the discover as a expression.
I don't think it likes what we're doing.
Or if you don't repeat it, if you remove repeat and remove seek.take and just fold over the command list, what's going on? Does this work? Does it give us a dash and not? Let's try that. Let's just run that. See what happens now.
You can't run it yet, I don't think.
Right, we're definitely getting a dash here, so that's okay. So it's to do with what we've got going on, right? So repeat should work. This repeat should repeat the commands X times. So let's do a repeat and then take. So let's ignore that. Let's try it in the FSI. Let's try repeat in the FSI. Let's play around with repeat.
And then do
Pipe
this
it to take, yeah. And just take 5.
Not too help it, does it?
So repeat might be doing something weird, right? While true do yield items. Just do, yeah.
Do that again. Now.
And instead of using a command list, use a 1, 2, 3, 4 piece, so that we're not convoluting the two issues.
Oh, what am I doing?
Just do a range, right?
Mm-hmm.
Yeah, it should be good enough. Well, that's working. So why is our commands? Why is it not working when we're passing in commands? That's the question, right? The question is something is going wrong when we're passing in commands instead. Right, it's literally resetting your FSI when we're passing in commands.
Dash length, that's fine. So let's change that to 45. 45. Doesn't like our command list. I think this needs a lot more research than what we can do now.
And if you wrap pen down and pen up as well, what happens? I mean, it's not going to know what pen up and pen down are because you haven't defined. Oh yeah, you would do.
Yeah, it'll be fine. I think we just need to research this.
Can you put a lambda in a list in the FSI?
Yeah.
Put a single lambda repeat list and then try and repeat it 3 times.
What do you want to do?
So repeat, open square bracket, and then give a lambda.
What do you want to do with this? I don't know.
Just some function. I don't care. Just pass some function.
I have no idea what to pass in as a function.
Just create a function that takes in 1 and doubles it. So takes in an argument and doubles it. It doesn't matter what the function is.
So that's not going to work, is it?
Good enough. And then take 3 or something.
Ain't gonna work.
That's the syntax thing, right?
Yeah.
How can you create an anonymous function then, so that you can get the syntax right on this one? No, like, what's the? Let's figure out what this. Just put it in parent, right? That should sort it out. Go back to the FSI and just go up and put the function in parent. That should work, right?
You think?
Try it.
I think so. I don't think you can do that.
That's really interesting. So what is? It's because yield, if it finds what's the behavior of yield? It's going to be a do yield that's behaving with items, that's behaving strangely with functions, right? There's going to be an interaction between yield and the fact we've got functions that we're passing into yield.
I'm not sure. I'm sorry.
Okay.
I'm out of ideas. I think we just need to research it and see what we've done. I've caught a bit off guard here tonight.
It's quite an interesting thing, though. I mean, we're trying to do this repeat function. I mean, there's a much simpler way of doing it, but this is really kind of clear and idiomatic to use repeat to repeat a list and then take n from that list as appropriate. But for some reason, it's turning out that this the repeat recipe that we're using, this let repeat items, is causing some interesting issues. And I'm wondering whether it's the yield that's interacting with the list in some strange way. Yield is interacting with the items inside the list. I don't know. Worth looking into.
Yeah. Yeah, so don't want to really hold you guys up for much longer with my very, very bad coding. So we'll let you guys go. We'll go and do some research and we'll come back with the answers to what we need to do to achieve this. Thanks for being patient with us, guys.
Thanks. And we guarantee you the videos on the course will be a little bit more instructive than this evening has been.
Definitely.
For sure. Anyway, I hope you found something useful out of it. I hope you got something out of this. And we will come back to you with a definite answer on how to use yield and functions and how to repeat a function list, because it seems like something that you'd really want to do. And that could be quite a powerful thing. So if you can't, we should find an easy way of doing it. Probably something really stupid we're doing.
Oh, definitely.
All right. Thanks a lot for your time. And
Thank you, guys.
See you on the course. Bye.